What up, Eastview Scholars? And my question for you today is, what's the matter? Are you teased by your friends because of your mass to volume ratio? What is density and how do I solve for it? We'll be answering these questions on today's edition of Sharp Short, starting with what's the matter? Matter is everything. Matter is anything defined with mass and volume, as we talked about in an earlier edition. So, all the stars in the solar system, everything they're made of, the atmosphere surrounding them, everything in this picture of this handsome cross-country team with the runners, the clothes they're wearing, the trees behind them, the grass they're standing on, the shoes they run in, okay? The animals here, they have a defined mass and they take up a certain amount of space, as does the air they breathe and everything around. So everything around us is matter. Matter is made up of atoms, must take up some space, that's the volume. They must also have some weight, that's the evil chemistry word. We use mass. What's the difference? I'll leave that for you to figure out, but subtle hint, this has a G word associated with it. So, density is a property that is unique for all matter. The 92 naturally occurring elements on the periodic table all are made up of different numbers of protons, neutrons, electrons. And they bind together to make molecules. Those molecules make macromolecules in everything that is matter. So everything that is matter has its own density. Every separate, unique, has its own unique thing. Gold does not have the same density as silver. Water does not have the same density as gold. You do not have the same density as your dog. Okay? So it's a very unique identifying feature. And it tells you how much mass, which is defined as the amount of atoms, in a certain volume that those atoms take up. Now, matter has two different properties to talk about, extensive and intensive. Extensive properties are those that depend on the number of atoms present. So mass is an extensive property. Volume is an extensive property. How come? Because those two things will change if you add or subtract matter. So I'll write an E here for extensive. Density, though, is the ratio of those two. That's an intensive property because it is a ratio that never changes. So if density, excuse my writing with the pen, is mass divided by volume, or the ratio of mass to the given volume, that ratio will stay the same because as I increase the mass, I will also increase the volume at the specific ratio that I'm adding those atoms. And if I decrease the same way. One of the key points, though, is density is a unique property that can tell you and help identify the substance that you're working with. Just for your understanding, other intensive properties include things like color. Okay? Now, this just goes back to the point of saying what is matter. Matter is anything that is defined as anything that has mass and volume. Density is the ratio of that mass to volume. Okay? So how do I work with this? It's a key component in the mathematics of chemistry. How do I work with it? Well, here's my formula. In however algebraically you want to maneuver it, here is density as mass over volume. If I happen to be solving for mass in the problem, then that's density times volume. If I need to know the volume, then that's mass divided by density. So all we did here was manipulate our initial formula algebraically to define maybe the one thing I'm looking for. And again, remember, density is a ratio, therefore you will always have some units of mass to volume. For example, it will always be grams per milliliter, or pounds per inch, or, pounds per inches cubed, grams per centimeter cubed, pounds per liter. I'm trying to think of every crazy one I can think of, but it would be some relationship of mass to volume. Okay? Let's look at a couple problems. Here's one. What is the density of an object with a mass of 54.5 grams and a volume of 21.8 milliliters? Well, my formula there, I'm looking for the density, is density equals the mass over the volume. Okay. which I have those numbers, so I just plug them in. 54.5 grams. My good dimensional analysis says keep the units with me, over 21.8 milliliters. Okay. And then I simply divide, and my answer comes out to be 2.50 grams for every milliliter, which I can write this way, grams per milliliter. In other words, that substance, every 2.5 grams, will occupy 1 milliliter of space. Now let's look at this. What is the volume in liters of gold if the density is 19 grams per milliliter and you have a 7.5 gram chunk? Now, we can rearrange. We know from the previous slide that volume is equal to mass over density. So I can plug in those numbers and I can solve and I can get the volume. What I hope you notice is that it asks you for the volume in liters, but it gives you the density in milliliters. Now, I can certainly just solve this out, get the mass volume in milliliters, and then convert it using my dimensional analysis to liters. But if I understand my dimensional analysis, I can actually do both the conversion and the density solving in one fell swoop. If I remember that when mass is divided by density, that's essentially multiplying it by the reciprocal. So I can start with my 7.5 grams. And rather than divide by the 19 grams per milliliter, I can multiply by and set up a conversion ratio where it's essentially flipped, where I'm saying it's 19 grams in every 1 milliliter. And then what I see is I can cancel the grams out. And now I have my milliliters and I want it in liters. Well, 1 liter, pardon the L, is 1,000 milliliters. And what I see by dimensional analysis is I've canceled out everything but the liters, so I just do the math, which turns out to be 7.5 divided by essentially 19,000, or it comes out to 3.9 times 10 to the minus 4th liters. Or about just under 0.4 milliliters, which makes sense if I look at my numbers and my mass is slightly under half of my density, then the volume will be slightly under half. Anyhow, that's density. I hope you figured out what's the matter and you have a good answer if anybody's teasing you about your mass to volume ratio. Either way, that finishes this version of Sharp Shorts Scholar on Eastview